Alright, I just want to make this quick video going over AQA's A-level Further Maths 2022 Paper 1. This is the final question and I thought it was fairly interesting on the paper, so I figured I'd do a full explanation for it. So part A here says, find the solutions to z to the 5 equals 1, giving your answers in the form cosine theta plus I sine of theta. The way you go about solving this one is it's sort of a fact you have to know. It's z to the n equals 1. It has the roots of z equals e to the 2k pi over n lots of I. And using that, you can find the roots for z to the 5 equals 1, because they're going to be z equals e to the 2 pi over 5i, e to the 4 pi over 5i, e to the 6 pi over 5i, e to the 8 pi over 5 lots of I, and then e to the 2 pi I is just going to be 1. So there are your roots in this form, but remember it asks for a specific form of cosine theta plus I sine of theta, and I forgot to mention the k here in the general expression is just the integers running from 1 to n, and then using these we can give the roots in the requested format. It's just going to be cosine of 2 pi over 5 plus I sine 2 pi over 5 . I won't go through the hassle of writing all of these down because it will be very repetitive, but for the last one here, when it gets to e to the 2 pi, it would just be z equals cosine of, well, 2 pi plus I sine of 2 pi, which cosine of 2 pi is just going to be 1, sine of 2 pi is just going to be 0, so that's what the last expression would be. But yeah, that's the answer to part A. I will flip over and go to part B. And this part says that using the equation 16c to the 5 minus 20c cubed plus 5c minus 1 has root c being the real components of the roots for z to the 5 equals 1, show that the equation has repeated roots. The way I went about solving this one is I just went with writing the expression as c minus, apologies, let me raise this up a bit, c minus cosine of 2 pi over 5, just factorising out from the roots we were given earlier, c minus cosine of 4 pi over 5, c minus cosine of 6 pi over 5, c minus cosine of 8 pi over 5, and c e minus 1 is just going to be equal to 0. And then using the cast diagram, you can find that cosine of 2 pi over 5 is actually exactly equal to cosine of 8 pi over 5, and that cosine of 4 pi over 5 is equal to cosine of 6 pi over 5, and that would give you this final expression of c minus cosine of 2 pi over 5, which is all squared, c minus cosine 4 pi over 5, all squared, c minus 1 equals 0, and that's how you show there are repeated roots for this equation. Going on to part C here, it asks, well, z to the 5 equals 1 forms a regular pentagon OA equals OB equals OC equals OD, which equals OE. Using the equation 16c to the 5 minus 20c cubed plus 5c minus 1 equals 0, going to make sure the full question is on view here. Show that the distance from O to AB is h, which is equal to 1 plus the square root of 5 all over 4. For the solution for this here, I used de Moivre's theorem, which is not actually given on the advanced information for this exam, despite being worth 6 marks, I believe. And I'll just go through the solution for that. It is, well, cosine of theta plus I sine of theta to the power of 5 is going to equal cosine 5 theta plus I sine of 5 theta. And just using binomial expansion on this bracket here, we would get I sine to the 5 theta plus cosine 5 theta plus 5I sine theta cosine to the power of 4 theta minus 10 sine squared theta cosine cubed theta minus 10I sine cubed theta cosine squared theta plus 5 sine to the power of 4 theta cosine theta. And then taking the real components from this expansion, it would get that cosine of 5 theta is going to equal cosine to the power of 5 theta minus 10 sine squared theta cosine cubed theta plus 5 sine to the power of 4 theta cos theta. And now replacing sine squared theta with 1 minus cos squared theta in all terms for this, we will get an expression for cosine of 5 theta. So I'm just going to quickly replace these, and this one's going to be squared since it's cosine to the 4. Without showing the full simplification of this, I will just simply conclude that it does come out as 16 cosine to the 5 theta minus 20 cos to the cubed theta plus 5 cosine theta. And if you'll recall from the top of the question here, matches up with 16c to the 5 minus 20c cubed plus 5c, but there is a minus 1 at the end. What I'll say is that, well, 16c to the 5 minus 20c cubed plus 5c has a range of, for theta, of minus 1 and plus 1. And the points along each vertex produce a maxima. So, using that, we can write the cosine of 5 theta minus 1 is equal 16c to the 5 minus 20c cubed plus 5c minus 1. This whole part here is just going to equal 1, and then you got to tack on the minus 1 at the end, which is going to equal 0, and that gives you that cosine 5 theta is equal to 1. So that will give you 5 theta is equal to the inverse cosine of 1, which is just going to be 0, 2 pi, 4 pi, etc. And you'll recall that's how I can show that this statement is accurate, because it gives you the angles for which are drawn to each vertex on the pentagon, 2 pi over 5, 4 pi over 5, etc., which we showed in the previous part of this question. So I'll just flip over real quick. For this last part here, we can write that cosine of 5 theta minus 1 is equal to 16 c to the 5 minus 20c cubed plus 5c minus 1. And for this point, which is h, the shortest distance from O to AB, it's going to produce a minima. So this part here is going to equal negative 1. So we get the cosine 5 theta minus 1 is just going to be equal to negative 1 minus 1. So it's going to equal negative 2. And then it gives us that cosine 5 theta is equal to negative 1. And using that, we can find that theta is equal to pi over 5. And then I'm going to quickly draw a diagram for the pentagon, or at least the parts which contain the edges. I'm gonna draw my diagram for the vertexes A and B. The full diagram is given in the question at part A, but it's only really relevant at this part. So I'm just going to draw my quick diagram, and it's the shortest distance is going to draw a tangent towards the edge of the pentagon. We have our angle here, which is pi over 5, and then we know that this point here is just 1, 0, because it's cosine 2 pi sine of 2 pi, as shown from part A. And then using this, we can use that cosine pi over 5 is equal to the adjacent over the hypotenuse, just basic trig rules. And this is going to show that cosine pi over 5 is equal to our length from O to AB, which is going to be h divided by 1. So then we get that h is equal to cosine pi over 5, which turns out to be exactly equal to 1 plus the square root of 5 over 4 as required.